In this module, we're looking at some key concepts associated with statistical hypothesis testing. I want to end this module by working through a real-world example. The research question for us is there truly such a thing as a home advantage in baseball? Conventional wisdom is that in baseball, in all spectator sports, the home team enjoys somewhat of an advantage. Is this really the case, at least in Major League Baseball? So let's work through this. Let's begin by stating our hypotheses. In this problem, what is our null hypothesis? What is our alternative? The null hypothesis is no effect, nothing is happening, that there is no advantage, versus the alternative that something is happening, something is going on, that there is a home advantage. Again, the null hypothesis is always nothing special is happening here. Usually the alternative is what we are trying to show. Once we've stated our hypotheses, we need to quantify them. What does it mean for the home team to have an advantage? Well, we could quantify this in several ways. Maybe we're saying that the home team scores more runs than the visiting team on average. But there's another way, and a simpler way we could do it, because ultimately what matters is not how many runs you're scoring, but whether or not you're winning the game. And so our null hypothesis might be, if there's no advantage, and you're playing half the games at home and half on the road, your chance of winning is 50-50 overall. And if you've got an advantage, it's bigger than 50-50. You do better at home. Once we've stated our hypotheses and quantified them, it's time to collect our data. I got data from the 2019 Major League Baseball regular season. I used last season rather than this season because maybe this season is unusual because of the COVID epidemic and the procedures in place there. So most recent regular season games. And in 2019, the home team won 1,286 games and lost 1,143. At this point, step 4, we need to compute a test statistic and a p-value. I encourage you to pause the video here to do so. Okay, the home team in our sample won 1,286 times out of this total number. The home team won just a smidgen under 53% of the time. To get a test statistic, we will, of course, draw a picture. Here's our picture. We expect 50-50, that's our null hypothesis value. We observed right at 53%, and we're interested in this area up in here. Notice we are not interested in this area down here. If the home team wins fewer than half of its games, there's no way we're going to conclude it has an advantage. In other words, what we have here is what statisticians call a one-tailed test. We believe that if anything is happening, it's happening in one direction and one direction only. Notice that's different from a lot of our previous examples. The coin toss could have gone either way, but home advantage is only in one direction. we still compute test statistic and p-value essentially the same way. Observed minus expected over standard deviation, observed at 53% minus expected, p, 1 minus p. There were 2,429 games. And what we observed is 2.9 standard deviations above the middle. Now this area up in here is the same as the mirror image down here. It's easier to look up the negative value and find just the one tail. The point is that this tail and this tail are the same size, and we only want one of them. We're not multiplying by 2 here. What do we do with the p-value that's 0.002, that is smaller than our traditional 0.05? We reject our null hypothesis. And by rejecting our null hypothesis, what conclusion do we draw? Because we don't care about hypotheses, we care about baseball teams. By rejecting the null, we're saying, yes, there is evidence. There is reason to believe that there is a home advantage in Major League Baseball. It's not a huge one. It helps your chance of winning by about 3%. But it really is real. The result is statistically significant. Notice here, we used a one-tailed test. And we will do so if, before we look at the data, we've got reason to believe that something is happening in one particular direction. We think the experimental drug helps cure people, not make them sicker. We think the home team does better, not worse.